Okay, so take a look at what we have here. We got f of x is equal to 1 over the square root of x minus 2. So when x equals 2, I end up with a 0 in the denominator. So this function is not defined at 2. I have a vertical asymptote at 2. That makes this a type 2 improper integral. As such, I can use the rules for improper integrals type 2, and I will now take the limit as t approaches my problem area, which is 2, on my integral from t to 5. X. Okay, so basically I'm going to go ahead and take the antiderivative of this. Uh, if you want to just kind of view this function as really x minus 2 to the negative 1/2. You're going to add 1 to that exponent, which is going to make it a positive 1/2. And you're going to divide by your new exponent, which is 2. That's my process of taking the antiderivative. Notice that you don't have to worry about the inside, because if I take the derivative of this using the chain rule, I end up with what I originally started off with, because when I take the derivative on the inside, it's 1, so no worries there. Okay, that's important. So there we go. Now I have the limit as t approaches 2 of 2 square root of x minus 2 from t to 5. Okay, I'll go ahead and plug those in. Plugging in 5 first, so let's see, 5 minus 3, I'm sorry, 5 minus 2 is 3, so I have 2 square root 3 minus 2 square root t minus 2. Okay, easy to take the limit of the first. It's simply going to be 2 square root 3 minus the limit of the back. Let me go ahead and rewrite that for just a second before I evaluate it. 2. And what you want to notice is this is now defined at t equals 2, so I can use direct substitution and plug in my 2. 2 minus 2 is 0. So all of this becomes 0. And I end up with 2 square root 3 as my final answer. Hopefully this makes sense. And again, I now have improper integral type 2, which is convergent to 2 square root 3.